Root mean square or virtual or effective value of AC. It is defined as that value of a direct current which produces the same heating effect in a given resistor as is produced by the given alternating current when passed for the same time, and that is denoted as IRMS. So it says that the RMS value is that value of a direct current. So for DC, if the current is I is flowing through a circuit with resistor R and the heat produced is H, then if the same heating effect is produced in an AC circuit for the same time T in the resistor, and that value of current will be called as IRMS, that is the root mean square value of AC current or effective value of AC current. So it is defined as that value of a direct current which produces the same heating effect in a given resistor as is produced by the given alternating current when passed for the same time, and that is IRMS, IB or I effective. IB means I virtual current. Now let's find the relation between the effective value and peak value of AC. Suppose an alternating current I equals I naught sine omega t. So our alternating current is this, and this is 0 t by 2 and t. So the current is varying as I equals I naught sine omega t. This is be passed through a circuit of resistance capital R. Then the amount of heat produced in a small time dt will be. So from the Joule heating effect, we know that H equals I square RT. So for small time dt, the heat produced will be dH. So this is dH equals to I square R dt. So heat produced in the resistance R. So dH equals I square R dt. Now if T is the time period of AC, then heat produced in one complete cycle will be. So in one complete cycle, the total heat produced will be, let's take the integration. So H is equals 0 to T I square R dt. This is the one heat produced in one complete cycle. Now let I effective be the effective value of AC. Then heat produced in time capital T must be H equals I effective square RT for effective value of AC. Now we can equate this and this equation. So I effective square RT equals integration 0 to T I square R dt. In the next step, we can, since R is constant, so we can cancel out R and this R. So I effective square can be written as 1 by T. Let's divide T. So 1 by T integration 0 to T I square dt. This term 1 by T I integration 0 to T I square dt is the mean of the squares of the instantaneous value of AC. So this whole term, this is the mean of the square of the instantaneous value of AC current over one complete cycle, obviously 0 to T. Hence the effective value or virtual value of AC equals its root mean square value, that is I effective is equals root under this term. So I effective is IRMS root under 1 by T 0 to T I square dt. This is the IRMS or I effective value of AC current. Now let's find 0 to T I square dt. So integration 0 to T, I is our I naught sine omega t. So I square will be I0 square sine square omega t dt. I0 is constant, so let's I0 square outside. So now sine square omega t. We know that 1 minus cos of 2 theta is equals 2 sine square theta. So we can replace sine square theta as 1 minus cos 2 theta divided by 2. So in this case it would be 1 minus cos 2 omega t divided by 2. Now in the next step, let's take 2 outside, so it will be I0 square by 2 and integration of 1 minus cos 2 omega t dt. Now integration of dt is t and integration of cos 2 omega t dt will be sine 2 omega t divided by 2 omega, since integration of cos x is sine x, so it will be cos 2 omega t. Since integration of cos mx by dx is equals sine mx by m, so in this case it is sine 2 omega t by 2 omega, and the limits is our 0 to t. Next step, I0 square by 2. Let's put the limits, so it will be our t minus 0. For this one it will be capital T minus 0, and for this it will be our minus 1 by 2 omega can be taken outside, 1 by 2 omega, and for this term let's simplify it first. So sine, we have taken the 2 omega part outside, so 1 by 2 omega, and sine of 2 omega is our 2 pi by t into t. Now if we put the limits, so 0 to t, this is our 4 pi by t, so sine 4 pi by t, upper limit is t minus sine of whole part is sine 0. So t and t gets cancelled, and sine 4 pi is 0 and sine 0 is also 0. So this part is contributing nothing, only 0. So we are left with I0 square by 2 into only this term, that is t. Here it is 1 by 2 pi sine 4 pi minus sine 0. So this part is contributing nothing, so this is 0 and only we are left with this part. So this is our I0 square t by 2, and this was our this term, only this part. We have to find the I effective, so let's write it. So I effective or I RMS is, this was our only I square dt part, 0 to t. Now I effective or I RMS is root under 1 by t, 0 to t I square dt. So let's put this value, so it will be I0 square t by 2, and t gets cancelled, so it will be our I effective or I RMS equals 1 by root 2 I0. 1 by root 2 is 0.707 and I0. So I effective or I RMS is 1 by root 2 I0 or 0.707 I0. Thus we can say that the effective or RMS value of an AC is 1 by root 2 times its peak value. So I RMS is equals I0 by root 2. This is the relation between the RMS value and the peak value of AC current.